Before we start building the neural network, we first need to understand the structure of the neural network. A neural network is a group of neurons that are inspired by the neurons in our brain. And the group of neurons creates a layer. There are three types of layers: input layer, hidden layer, and an output layer. And the goal of the input layer is to pass the input values to the hidden layers. Now let's take a closer look at the hidden layer. Let's say our neuron has two inputs, X and Y. And each of these inputs come with their own weights. And the neuron has a bias. To get the output Z, we multiply the input value with the corresponding weight, twice in this case, and then add the bias and pass it through an activation function. Then we do this for the entire layer using matrices. Then during training, we compare the output to the desired output to get the error gradient. And this entire process is called the forward pass. And this is only the first of two steps in machine learning. And step 2 is called the backward pass or backpropagation. The goal of the backward pass is to figure out exactly how much each weight and bias contributed to that error so we could adjust them. There are three main steps in backpropagation. Step 1. Remember how we changed the final answer using an activation function? In this step, we have to multiply the error gradient with the derivative of the activation function, and the result is called delta. Next, we have to do the same process to the hidden layers as well. But there's a problem. We don't have an error gradient to compare to. So we take the delta of the output layer, multiply its weights connecting to the output layer, and multiply that by the derivative of the activation function, and the result is called the delta of the hidden layer. Now we have to do step 1 for all neurons in every layer. Then we have to find the gradients of the weights and bias. To get the gradient for each weight, we have to multiply the delta with the input of the neuron. Remember when we were calculating the output, we added the bias? Because it has no constant attached to it, the gradient of the bias is delta itself. Now we reach the final step in training, which is to update the weights and bias. In order to do that, we have to multiply the weights gradient with the learning weight, and this result is subtracted from the original weights, and do the same thing to the bias. You might notice this new word called learning rate. This is a parameter that controls how fast your neural network learns. And repeat step 1 and step 2 thousands of times, and you have a neural network that learns. Now